Okay, welcome to lesson 4. We have Cheyenne, Marlise, I was going to mix those two names together, and Stacy. And we're doing the first week, the first part of the first week's prep. So we kind of discussed before that this week was a lot easier than all the other weeks. And so we were just going to kind of jump right into the 2 prep works that it said to do, number 5 and 6. And then we were going to go into the quiz. None of us really had any questions about probability. I mean, it was fairly self-explanatory. So this meeting probably won't be as long as our other meetings, but you never know when we take the quiz. Who knows? We might surprise us. So we're just going to jump into questions 5 and 6 where it says the probability. Stacy, do you want to take us there and read the question?
Sorry. My throat's all messed up. An 8-sided die has 8 possible outcomes for each roll. 1, 2, 3, 4, 5, 6, 7, or 8. Calculate the probability of rolling a number greater than 5. So we know that the notation that we have to use is the P and then in parentheses X, which is going to be the roll greater than 5. So if there's 8 possible outcomes, then if we want to do greater than 5, it would be 6, 7, and 8, which is 3 over 8, right?
Yep, I agree.
Yeah. Okay.
So then we get 0.375
Okay.
with that. Or
So
round it up, 0.38.
Okay. So either way is right?
Yeah.
Okay.
I don't think they want us to write both of them. I think probably like when it comes to the quizzes, it'll probably be in fraction form or in decimal. I mean, maybe it'll say or, I don't know. Okay. Jordan, my child in the background. All right, I'll do 6. Calculate the probability of not getting a number greater than 5. So we know that there are 5 numbers that are not greater than 5 with our 8 dice. So 5 over 8 or 0.625. Yes?
Yep, that sounds good.
Okay. I don't know, one thing we could bring up, it was interesting to read about random, how it's not just a haphazard way that it said. It's like, oh, it's not just haphazard. Like it really does have a long-term pattern in its distribution. We just don't know the outcome. So that was interesting. Because when I think of random, I do think of haphazard. And so I was like, oh yeah, I guess it wouldn't be random. So that was interesting. Just going over our other notes, see if there's anything else. The 3 rules are always good. The 3rd rule, where the probability that an even will not occur is 1 minus the probability that will occur. That's a nice rule because that's going to become super convenient, I feel like, when we're trying to figure everything out. Just be like, oh yeah, perfect, -1. But all right, so I'm going to pull up. If we all want to pull up our quizzes. Okay, mine is pulled up.
I'm good too.
Yep.
Okay. Marlise, if we ever lose you or anything like that, just
I'm here.
Text me.
I'm here. Can you hear me?
Yep.
Mm-hmm. I just went ahead and just turned the camera off while I'm taking the quiz since I'm not using the best internet.
Perfect.
Okay.
All right. I will go over question 1. Well, the first, whatever one that starts. Oh, so it does say give all your probability answers as decimals.
Mm-hmm.
Okay.
Do not give probability as percent. Okay. So use the following information to answer the next 3 problems. Human blood can be classified into one of the 4 types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. So the blood types and the proportions given in the table above define a probability distribution. True or false?
So true, right? It's between 0 and 1.
Yeah.
Yeah.
So between 0 and 1, that all matches up. So true. What is the probability that a randomly selected person in the United States has type O blood? Round 2 decimal places. So we look at the O. So 45%. Oh, wait. But wait, it didn't want us to do in decimal or in percentage form or something, right?
Right. Round. What's that? Yeah, all answers is decimals. So, so would it be 0.5? Or no? What are they asking for? What is the probability?
I mean, I want to round to 2 decimal places. I want to put 0.45, but is that too obvious? Is that wrong? Anyone?
No, I think that's right.
I was trying to figure that out too, because like
Hmm.
when you're thinking about rolling the dice, the probability of rolling a 1 would be 1 out of 6. So when you're talking about the same idea but blood type and you've already got the decimal,
I think it's 0.45. I think
Yeah.
put 0.45.
Okay.
Well,
We'll
if we
see.
get it wrong, we'll take it again. Okay. Okay, Stacy, you want to do the next one? 5?
Says, what is the probability that a randomly selected person will not have type O?
Huh?
okay,
So then it has to equal 100, right? So would it
Yeah.
be like 55.55?
yeah,
Yeah.
I think so.
Right? 0.50.
Mhm.
0.50, right?
I mean, 0.5.
No.
55. Sorry, 0.55.
Yeah.
55.
Yeah.
0.55. Sorry, not 50. Because it has to equal 100. So
100.
That's what I.
Yeah, that seems right to me.
all right, Marlies, you want to do 6?
Yeah. Okay. Do you want me to read the paragraph first?
Yeah.
Okay. And you guys can hear me just fine, right?
Oh yeah.
Mhm.
Okay. Carolyn Wills and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. The question is, if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round answer to 3 decimal places. Okay.
So 1 and 6, right? There are 6 samples.
Right.
Oh
Yeah,
no, 7.
So
7.
7.
Seven.
The total.
But 6 of them were patients who did not have bladder cancer.
So it would be
But there were 7. So wouldn't it be?
0.166, right?
Wouldn't
Did I
it
do
be?
that right?
So what the probability would be 117, right?
Oh, 3.
Or would it be 1 and 6
I think it'd be
Well-
7 because there's 7
bowls that they're picking from,
total.
right?
Yeah.
So 1 and 7, that they'll get
But
it
you
right.
have to do 1 divided by 7, right?
Yeah.
So that's 0.14. I'm rounding up to 0.143.
1, 4, 3. Okay.
Okay.
For some reason, my calculator won't show me any more decimals. I don't know how to make it, but whatever. We'll just rely on your guys's. I'll just use my phone, not my smart calculator. Okay. All right, Cheyenne, you want to do 7?
Yeah. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random choice chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there's little evidence that dogs can detect bladder cancer.
Total of 54 trials, 22 times.
Yeah, and I would think there's little because they didn't even get half. I mean, correctly. I don't know.
I think that we got it right 41% of the time if you're rounding up.
Yeah.
So if you think about it, I mean, it's not even half the time. I mean, it's an incredible amount, but
The question states it is very unlikely the dog would do this well by random chance.
Right.
Yeah, why do they have to throw that into make us all confused?
But it does say, I mean, this is the thing. I hate with wording because we can always play with it, like dogs in general. Like if you didn't randomly train this dog, if you didn't train the dog, they're not probably going to guess it. But so is it asking dogs in general or only this specific dog group, you know?
Yeah.
So maybe that's why we could say there's little evidence.
Mm-hmm.
Because if it was like 70% of the time, I'd say there's strong evidence.
Yeah.
so, but this is the other thing. I think but since even the question states that it's unlikely the dog would do it by random chance, there is some evidence that dogs can detect bladder cancer. They just can't detect it accurately every time.
Yeah.
Right.
So that's why I'm kind of leaning towards the strong evidence.
Well, we have two options and we can take the test twice. So this provides strong evidence that the dogs can detect bladder cancer. That's what we're clicking.
Okay.
For now. All right. 8. For the next 3 questions, we're going to use this little M&M thing to indicate that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. Pretty sure in 6th grade I did this as a science project. All right. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? So the probability, 0.13.
Yep.
Sometimes I feel like that's got to be wrong because it's so easy.
Too easy. Right.
I know, I agree.
Well, I hope that we turn this test and it's like, oh, 0, 0. What is the probability that a randomly selected candy is green? So,
Oh, okay. So let's just add up those numbers.
and then to make sure we get to the 100 part, whatever.
Yep. I got, oh, whoops.
I got 16, so 0.16.
Yeah.
Everyone else get 0.16? Nice. Okay, what is the
I had to do
probability?
it over again.
Is it right?
Maddie? What did you guys get?
0.16?
I had to do it over again. 0.16. Yeah.
Yeah, okay. What's the probability that randomly selected candy is not green? 0.84.
Mm-hmm.
Why does it matter? You should get inside.
Okay. All right. Cheyenne, you could go.
The ACT scores of students admitted to a medium-sized public university in the western United States were taken from packets.com. The following summary statistics were calculated. Question 11. Half of the observations are less than or equal to what number?
Okay, so
Half of the observations are less than or equal to what number?
man, I'm confused as to what they're wanting.
I don't know what they're asking.
As review in parentheses. So what does that mean? Review.
From last week, I think.
Oh, really?
Oh, is this like
'Cause,
the
yeah, the minimum, maximum, standard deviation. That's all.
is this the standard deviation? Is that what this is asking? Standard deviation? Review.
I mean, it's stating, I guess, all that stuff here, but I just
Oh,
want
or is this the mean? Half of the observations are less than or equal to what number? Doesn't want to know the mean of all these numbers, right?
so. Yeah, that would make sense.
24.3. Oh,
Yeah.
it tells us the standard deviation, 4.3. So is that what it's asking? Half the observations are less than or equal to what number?
Let's go with the mean.
Yeah.
Okay. Based on the information on the table, the top 25% of the students scored above what number?
So that would be
The top 25. So is that in the first quartile? The top 25?
So,
I think it would.
Top 25.
I guess
Wouldn't
that-
it be the third because that's like 75% or higher? Does that make sense?
Yeah,
No, because yeah, it's the top, not the.
not the bottom.
Right. So 27.
So yeah. Yeah, that is so tricky for me. Like I would have probably guessed the first because of the 25%. You know? Okay.
The third one for 13 is if the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The probabilities can never be negative.
Right.
Okay. All right, everyone. I'm just going to stop our broadcast. Good work. And then just for that part, then we could talk about whatever else we need to.